Okay, we're busy with our special registers, and we've looked at the what? At the circulating one. We've looked at the circulating one. We've looked at the ring counter. This was the ring counter. The ring counter, basically what did it do? It corrected itself first. Here it took 3 pulses to do that. And then what did it do? It remained with one single digit one, and it kept rotating it amongst its various outputs. All right, it kept circulating it. All right. So now what you then look at, we're going to look at the what at the last counter, which is the what, which is the Johnson counter. So with the Johnson counter, what I would like to highlight is basically what does it do? What is the purpose of the Johnson counter? The purpose of this Johnson counter is literally to what? To empty the register of ones, and then fill up the register with ones again, empty again with ones, and fill up again. So what I want to highlight first with the what I want to highlight first with the previous register is that something very important that we didn't highlight. What I want to highlight first is that here we did an example with 5 bits. It does not mean that it's always 5 bits. If I had what is important here is that the middle what call this flip-flops, they must feed back through the AND gate to the first one. The middle flip-flops must feed back to the what? So let's suppose it was a 4-bit. Let's suppose we've been asked for a 4-bit, and it would mean that we don't have what? We don't have a okay, that's fine. We don't have, it would mean that we do not have that bit. It would mean that we have only 4, meaning that we wouldn't then feed back from the last one. We would only feed back from the middle ones, and the middle ones, they are only what? They're only 2. So in this case here, this here would not be what? This feedback here would not be important. Let me rather change this and get rid of that once. Okay. Oh, it is all grouped together. Always happens to me. My kind of luck. It's my kind of luck. Now ungroup this and then try again. Okay, so then we wouldn't have this feedback. All right, so it will still okay. It will mean now a 2 input AND gate. All right, it would mean a 2 input AND gate because there's only 2 in the middle. All right, so the middle 2 would then feed what? So obviously we would not have had in the output, we would not have had this last output here. There, you have to be careful. So this wouldn't have been true anymore. All right, so it would probably have taken what call this, if this was the reading there, it would have taken 1 2 2 to correct in this case. But once there was 1 only, you can see it was already starting to what, to circulate. But obviously it would have jumped back to this one here. This count would have been what, would not be there. All right, it will jump back to that one there. So but it will, you can see that it will take a different number of pulses to actually circulate. Also it will depend on how many ones you had. All right, so basically the ring counter, it is not always, I can ask you for 3-bit. If I do ask for 3-bit, let's remove this because it's no longer really true. It needs some changes to be true. Now if I ask you for 3-bit or for 4-bit, that's what you do. If I ask you for rather for 2, this is what, this was 4-bit. If I ask you for 3-bit, then if anyone asks you, not me rather, so as if I'm gonna everyone is gonna be taking my exams or tests. So if it was only, if you only requested to supply 1 with what, with 3 bits, then only the 1 in the middle would feedback, because now there is only what, there is only 1 in the middle. Remember the middle ones, in which case you would need a what, an AND gate, only 1 would do. Okay, so it's not always true that when you say the ring counter it must be 5-bit all the time. Now let's suppose if it's not specified how many bits, it should be within reason. You should be able to what, to do 3 bits, and no one should hammer you for it. But of course, if I said a 4-bit or 5-bit or whatever, then you have to do it the way your examiner would have requested it. So now we are going to look at the what, at the final register, and this is the Johnson counter. Johnson counter. Okay, the Johnson counter is our third and final one that I'll look at. Want to probably remove this. Is not true for the Johnson counter. This was true for the ring counter. So for the Johnson counter, let's say I will have, oh God, what am I doing? It's a little bit difficult to draw. No, I'll give up to draw them straight. Ish, that is bad. Okay, why am I suffering? Why am I suffering? Okay, let's do one with four bits. So I could say, draw me a what? A 4-bit Johnson counter. And obviously, why would I use the JK? Because our shift registers are D, simply because it's versatile. All right, we can relate how it could be done with the different ones. Probably I should show so that maybe people can what, can know how to change if it was something else, if they were requested. I should probably do an example here. Let's say this was what, 4-bit, and that's what we would have, J and K. So what we want is the shift register. So what will happen is that is what is going to shift data. So it's going to behave like a, this is like a T, that is like a T. Y, we are fitting opposites. We are fitting opposites. Okay, if it's configured so that it's like we are fitting opposites, then it's going to what, it's going to do a very special thing. Now what I'll do is, oh, Q, all right, this one, and someone will say why, Mar, and that one, the output and the inverse of the second last, even if it was 5-bit, these are used. Oh, what am I doing? I usually draw my 8 that way for the AND gate. This one will come and reset. So could I have had maybe a 3-bit? Yes, these two would have come and reset only one. Since it's 4-bit, these two come and reset the what? Those two. If I had another one, let's suppose I had another one, I would have had a reset coming from that. So the last two reset the rest. So it can be, I can ask you for a 3-bit, in which case they only reset the first one. Now I'm doing an example with 4 bits, so we are resetting 2. But if it was 5-bit, you'd have to add the next one, and all you have to do is what? Reset that one there as well. All right. So that is basically what you need to know about what. It can be any number of bits. You can request you for any number of bits. Now, what happens with the first one is that we will then have. What am I doing? Almost erased. Oh God. That one coming. Aish. Time is money. I'm not gonna try to struggle to fight with this thing the whole time here. It's gonna be a little bit of a problem to try and what and fight with this thing. Now what we want to do also, we want to have our outputs Q to the power 1, 2, 3, 4. So that's 16. That's 8. No. What am I doing? That's 2 to the power 3. That's 8 already. 8, 4, 2, and 1. Okay, so the only thing is that you take that one there and feed it back to the other one. So if you look at this now, what we have now, this is a JK. The output, the Q is fitting back all the way to that side there, and then the not Q is fitting back all the way to the opposite, just like we did the JK. If you remember when we did the JK, what do you do with the not Q is fitting back to the opposite? Okay, so now what is then happening is that, however, that last one also comes with a not Q of the other one to come and reset whatever other bits you have. If you have 2, reset only 1. If you have if you have what does it? If you have 3 bits, you reset only 1. If you have 4, you reset what? I think I said if you have 2. I meant to say if you have 3, you reset only the 1. If you have 4, you reset the 2. If you have 5, if you have 7, you reset the rest of them. The last 2, reset the rest. Now, when you look at this, what is this? This is a register, so we would want to be able to what? To have a clock, obviously now. Okay, so if we have a clock, it's a shift register, so data is supposed to move simultaneously. So this is going to be a common clock, or what we call a synchronous arrangement. Okay, so this will be our clock, and remember it's JK, so everything opens. This is not only JK, this is what? This is not because it's JK, but because it's master slave. It happens what? At the trading edge. So now what then happens here? Let's then try and move this. I think most of my space is taken up here. I want to explain how this will work. What are we looking at here? We're looking at the Jensen counter. Let me rather have it up there. Okay, maybe it's okay there. Let me rather take my Jensen counter then and move it a little to that side. So probably I can have what? I can have a little space for the timing diagram. Let's say I have, again, I should have probably saved this somewhere. To keep doing this is really ridiculous. I'm trying to make them squares and I'm trying to rush, so we don't what? We don't take too long. We'll see if we need more. Now, what we then do is we have our Q. What I'll do is I'll start with my Q1 here. This is the clock. I'll start with my Q1, my Q2, my Q4, and my Q8. What did I do? Q1, Q4, Q421. Okay, 8421, 8421, which is fine. Now let's suppose I'm gonna have to mark. We used trailing edge type, so let me mark my trailing edges. I really hope that's enough clock pulses, because it may start by correcting, so it will depend on the fault we put in there. What do I mean by fault? I mean that, let's say there was a count somehow a strange count. I don't see why, because we have a reset function. We could make our life easy by resetting, but we want to show how, in the event of a need to correct, how this will actually correct itself, or how it will prevent errors by autocorrection. How it will autocorrect in the event of an error. Now, let's suppose that was a 1. that was a 0. I like to make it different. That was a 1, and let's say that was a 0. Okay, what do we then do? 1, 2, 3, 4, 5, 6, 7, 8. If we need less, I'll remove some, but probably it will take us a little bit more. We'll see. Now, with the 1, the first clock pulse, we have got 1, 0, 1, 0, 1. 0, 1, 0, 1. We have to pay attention and study what will happen next here. These are simple, they are fitting back. So they're just fitting through. So this is 1 goes to 8. That 1 slides through to 8. 0 goes to what? To Q4. It just slides through. That 0 slides through to Q4. Then that 1 slides through. It's just T-type. It's working like a T-type. Slides through shift registers. So this 1 slides through. And then what happens here? We had a 0 here. So the 0 is there, which gives us 1, 1, which is not going to do anything. We reset with zeros, but we have a what? We have a, if 0 there, that's a 1 there. So we have a 1, and that's a 0 there. We have a 0. The two are not the same, so this is indirectly configured like what? Like a T-type. So the 1 goes through. So the 1 goes through. Okay. Now we've got a new situation. The 1 came through. The 0 came through. The 1 came through. So we have a 1 on 8. We have a 0 on 4. We have a 1, 1 left. I already have a 1 there, so it's fine. So I put 1, 0, 1, 1. Then what happens? This here changes to a 1. Okay, that there is a 1 because it's 0 up, so it's going to be 1 here. So this is going to turn to 0, meaning change this to 0. Change that, because remember this becomes 0, so it can't be 1 there. It's 0, it's all one thing. So that also changes to, it says reset. Okay, so what will happen is the moment we had 1, 0 there, what happens? We automatically got what? So for a little time there, it might have taken a little longer, but then this will go back to what is changed. Q1, no. Or I have changed it already from the resetting. So Q1 is reset, and that one I'm putting a little bit of delay to say it would have happened after. So it won't have been immediately, it would have happened a little after, but then the rest would have stayed as what? 0. What am I doing? Okay, that one would have, okay, let me not go there, because now this should have been, let's first correct this. Let me first correct, I think I jumped the gun a little here. After we had 1, 0, 1, 1, what happens is that that one immediately goes to, we have 1, 0, 1, 1, 1, 0, 1, 1. That one does not wait. So the moment that these two were 1, 0, the moment that these two were 1, 0, those ones would have what? Would have corrected. Actually, the correction is supposed to be here. I missed the gun here. Okay, it was going to be a little time, because it was going to happen after this 1, 0, but this was going to revert immediately, because this does not wait to a 0, and this was going to revert immediately. Maybe slightly different times because the speeds may not be the same, but these two would have, I missed that. The moment these two became 1, 0, they automatically, remember, reset does not wait, so they automatically what? Reset. So it would have been a little time to show that it wouldn't happen instantly, but it would be slightly longer. Doesn't have to be too long, and then it would have reset to what? To that. Now we have 1 0 0 0, and what happens now? That 1 is fed here, and obviously that's a 0. This 0 is fed there. What happens next is that 0 goes to Q8. That 0 goes to Q4. That 0 goes to Q2. And this 0 here is behaving like a what? 0 1, it makes it act like a what? Act like a what? It will follow the what? The Q will follow the J. It will behave like a what? A D type. So that 0 is fed through. So this is 0 from the input being fed through from the feedback, but this is the 0 sliding through. That's the 0 sliding through, and that's the 0 sliding through. What do you see happening here? The register is filled up with zeros. Now, next pulse, what do you have? You've got zeros only. What does it mean? The feedback here is a 1, and the feedback there, how can they both be ones? Oh, that's a 0. It's coming from 0, and that is a 1. Now that's a 1. Okay, so what's happening here? This is 1. This here is 0, which means blocked. That goes back to 1. No resetting. 1. No resetting. So when you don't reset, this one stays. The thing is, the whole register is not going to act like a what? It's just going to shift. So 0 goes across. So the 0 from this one goes there. Q8 goes, Q4 goes to Q8. Q2 goes to the 0. Q2 goes to Q4. Q1 goes to Q2. It's a 0. All that has happened is that these have slid through. But then that one there fits a 1. So that becomes a 1. Next pulse is, let me clean this up. Because it is not going to be clear with too many disturbing figures here. We want to have a clean one so we do not have any confusions. Alright, I hope that's not too slow. Alright, what then happens is this. We have 0, 0, 0, 1. What happens now is that the 0 is fed back this side, obviously the opposite is fed there. Now, what's happening is that there is a 0 here blocking that. This stays 1, 1, no problem. This stays 1, 1. So, no resetting. What then happens is that it's just going to slide through. So, whatever is waiting is going to go through. 0 to 0 goes across to Q8. The 0 goes to Q, from Q2 to Q4. Q1 fed a 1 to Q2, but there's a 1 waiting there to be fed there. What happens now is, alright, let's first study. We have got 2 1s, only this part has changed. So if the last one didn't change, those ones don't change. Okay, so that one doesn't change either. So no resetting. So all you do is feed through. Whatever is waiting, Q4 goes to, Q4 is a 0, passes through. Q2 is a 1, passes through. Q1 is a 1, passes through. And we fed a 1. Now we have 3 1s. Okay, now we still have a 0 here, meaning that 0 is keeping things stable here. No resetting for Q1 and Q2. What then happens is that we still have a 0 there, so that's 0, that's 1. So we are still having our 1 there. What happens now is that we are fitting. We remember this is from the last count, that's a 1. So what happens now is we're fitting through. Q4 is a 1, goes through to Q8. Q2 goes through to Q4, Q1 goes through to Q2, and that one that is waiting there, what did I say, Q2, and I wrote a 2 instead of a 1. Okay, Q2 goes to Q2, but Q1 goes to Q2, but it's a 1. And then that one is 13, and we have got all ones. Now when we've got all ones, what happens? That's a 1. Okay, so since it's a 1, what happens is that we are going to then what? Have a 0 there, because the 1, a 0, these two swap around, and we have the 1 on K, and obviously the node Q is a 0. So we are fitting 0 to Q1, the rest are sliding through. So obviously you can see Q1 is being fed a 0, but that one is going through is a 1, that one is going through is a 1, that one is going through is a 1. So probably I need to move my work a little to show, and then now I'm gonna need to add a few pulses here to demonstrate what will happen. I think I need 3. I don't know if I've got space for 3, and I need 4 to just really show. I will not waste time with this. I'll just put general guides because I don't want to break the line of thought. Okay, just a general guide to not break the line of thinking. Now what happens is that we've got now we've got a 0 at the end, but that 1 keeps the status quo here. We have a what? We have a 1 there, and we have a 0 here, so that 0 keeps that 1s. The 0 from that keeps that as 1s. Alright, so now what then happens is, I don't know if we actually read it nicely last time. So we have got a 0 coming through there and a 0 being fed. So you can see that a 0 is coming through. Once we see what happens with Q1, Q1 feeds Q2, 0. That one feeds Q3, 1. So Q4, that one feeds Q8, 1. Next, we need to check that one is still a 1 there. Okay, we don't know. We look at this one, it's a 1. Remember, we now have 2 zeros. That's a 1, so giving us a 0. So these stay 1s. That one doesn't change because Q8 didn't change. So now, so we are still fitting a 0. So we've got 2 zeros being fed through and 1. Q8 will receive Q4, or let's look at this. Q1 will become 0 because we are fitting a 0. But the rest are just sending through. Q1 sends to Q2, Q2 sends to Q4, and Q4 sends to Q8. Okay, now we look, because he didn't change, because we've got 3 zeros now. He didn't change, so what happens? You've got that one not changing, but this one here becomes what? This one here becomes a 1. So 1 and 1, because this one here is a 1. Since that's a 1, 1 and 1 gives us a 1. So this here says reset. We reset. Okay, but then what's being fed there is still a what? A 0. So what happens is the 0 is still going to come through. So we're feeding a 0. That 0 goes through. That 0 goes through. This we fed a 0. That 0 went through. That 0 went through. That 0 goes through. So we have 0. Everything is zeros. Let's see what happens now when everything is zeros. This changes. That becomes 1, 1. This is 0, which locks the gate. Okay, so 0 locks the gate, so nothing happens. This 0 locks the gate, so nothing happens there. This is 1s. Okay, so nothing happens here, but we have a 0 on node Q and we have a 1 waiting now. All right, so what happens is there's no resetting and the data that is waiting is a 1, everything else sweeps through. So we have a 1 waiting, so the 1 is fed through. We have a what? We have a 0 being fed through, a 0 being fed through, and a 0 being fed through. Common sense says here we can see that if this is a 1, common sense says obviously we've been here before. We were here before. So the next step will obviously be that step there. We can now see that, oh, the next one there, for the same reason, would be that, a 1 there, and then that a 1 there, a 0 here, and a 0 here. Because if we were there, why would then the what? Why would this now act different? So what's going to happen now is that this cycle is going to repeat. What happened? We started off with zeros, it cleared this off, it started off to zeros, started filling with ones, there was 1 1, 2 ones, 3 ones, 4 ones. Now starts to fill up with zeros, 0 1 1, 1 0, 2 zeros, 3 zeros, what call this? So obviously this cycle will keep repeating. What does this register do? The Johnson counter, the counter fills the registers. The register, it's one register with zeros, comma, and then with ones repeatedly. As long as what? As long as the clock pulses keep coming. So we've done all our special registers, and then I hope that we understood how the things work. You see that both the ring counter and the Johnson counter started off by what? By correction, by correcting themselves. After correction, then what happened? You then realize that what? The register started what? It started filling up with zeros and then started filling up with ones, and over. It started doing that. Okay, so I hope everything is clear. We are done with shift registers. I hope we had fun.